Thank you, Adrian. Good morning, everyone. Hope you can hear me okay. Today I'm going to talk to you about our Muckanippie project in the Northern Gawler. The slide you can see there is the typical landscape there, saltbush country, woodland country. This is the southern slopes of our Rosewood prospect area. You can see typical sort of ironstone and silk-reeded terrains there. In amongst that saltbush, mapping team found some very interesting rocks, which I'll talk to you about now. Just moving on. Company's compliance statements. We also have our ASX releases listed there, so if you want any more information, please go to those ASX announcements. Just quickly, the company, corporate overview, 30 million shares on offer, market cap about 50 mil. We've had a nice uptick and hopefully that continues and it's not a flash in the pan. Now, Petratherm are a South Australian focused explorer. Bread and butter is copper and gold. We explore principally in the Olympic domain of South Australia. We've got two large project holdings, Woomera project holding on the western side of the Central Olympic province there. We've conducted a lot of gravity surveying and we have some fantastic targets. They're deep, but I guess Oak Dam has demonstrated that deep targets can be tested, and we hope to be testing some of those exciting gravity targets next year, along with our Muckanippie, our Maple Creek project in the northern reaches of the Gawler there. We think that's a very exciting terrain there. We have drill-ready targets there too. But today's talk's on Muckanippie, so I'll focus on Muckanippie. It's in the northern Gawler. How did we get there? This is a magnetic image of that northern Gawler area. We started in the Comet area, which is another project grouping we have just northeast of Muckanippie, and you can see at the top of the image there the Comet Gold project. That was a Cow Creek gold anomaly that was identified in the mid-90s by Minotaur and later drilled, and it was demonstrated to generate a nice little gold shoot there, similar to Aurora Tank or Challenger, and it was something that was always a bit of interest to me personally because I was a young geo at the time drilling, and when that ground became available we picked up that ground. I was also a bit of a skeptic on Cow Creek sampling. We knew that it didn't really work over a big part of the area, and I think a lot of the CRC lean research that followed after the initial Gawler gold boom in the late 90s demonstrated that as soon as you got 4 or 5 metres of transported cover, Cow Creek doesn't work that well. So what we did is we went out and drilled 1,000 holes to the top of the saprolite to use the top of the saprolite as a geochemical sampling tool, and that was funded 50-50 with the South Australian Mines Department, and we wouldn't have done it without their support. And that was a really interesting sort of R&D type campaign. It found some nice gold anomalies, but also found a lot of rare earths. And what intrigued us about those rare earths, and this was a couple of years ago now, as you know, rare earths were very popular a couple of years ago. Our rare earths are associated with magnetic complexes that we could see on the regional area magnetics, and you can see there highlighted the Meteor rare earth prospect, a little wishbone magnetic anomaly. We've got a whole series of these magnetic anomalies extending to the southeast. Along which would have been like a rift zone. On the other side of that rift, we've got Prominent Hill. It's a very important, I think, structural corridor. We're on the western side here. And you can also see in the central northern portion there, the Wirrada layered intrusion, which is presumably a time equivalent of those smaller intrusions. When we drilled those things, we found out that they were actually highly differentiated, very interesting chemistries, ultramafic components to them. They had high rare earths, high calcium. We even wondered whether they had carbonatitic type affinities. So as soon as we sort of latched onto that, interest peaked about the Muckanippie intrusion to the southwest. We thought Wirrada was probably a time equivalent, even though there had been no dating. And that sort of led us towards Muckanippie, where we've been building a ground position and started exploration a couple of years ago. This is a slide of the Muckanippie project tenement grouping. We have about 4 tenements there and a couple of joint ventures. The main joint venture area is with Nerea Metals, another ASX-listed company in the northern lease, EL6715, but we've got quite a big holding. There's been no detailed geological mapping of the Muckanippie suite. There's been a little bit of sampling, a little bit of work, and there's a lot you can be gained from the aeromagnetics. You can see it's a layered complex. If you look at the aeromagnetics, it looks like an onion that's been sliced in half. And a lot of the early exploration focused on testing high magnetic intensity bodies, such as at Wiggity on the western side there, you can see, which intersected broad zones of magnetite, peroxenite rock, also with high titanium, 5 to 8% titanium. Another prospect, M1, a single hole was drilled there, and it intersected broad intercepts of magnetite, peroxenite type rock again. These are later differentiated mafic intrusions that have popped up into the Muckanippie suite. And they're interesting, potentially bulk tonnage type ore, and that was our initial interest. We thought, let's look at this from a titanium vanadium point of view. We were finding also elevated PGEs associated with this layered complex. There was a single drill hole drilled at Claypan prospect there you can see on the eastern side, and that was a more subtle magnetic dipole anomaly that had been drilled by Tasman in the early 2000s, testing it for diamonds. And it had fantastic titanium geochemistry. We were seeing titanium values up to 20%. And as soon as you get above sort of 15% in basement, that's looking to be economic. The world's great basement titanium deposits, such as Telnis in Norway, has an average grade of about 17%. Lacteo in Canada, titanium magnetite deposit, that has grades around 30%. So that certainly piqued our interest. Our geological team, Sam and Barry, went out onto the field and we used, of course, Google Earth. We used to use those stereo nets back in my day. But they used Google Earth to identify areas where we thought might be subcrop. And I guess the important thing about Claypan was it wasn't particularly magnetic. And as you know, ilmenite really isn't magnetic. So your eyes as an explorer is drawn towards drilling magnetic anomalies, but we started to realise that maybe some of these more subtle magnetic features are of interest. So when they went out and did field mapping, this is sorts of things they found scattered in amongst the calcrete and the saltbush. On the left there is a silcreted sand with dark minerals. These minerals are, we thought initially maybe they're just mafic, some kind, pyroxenes or something, but we look at them and thought, well, the colour isn't quite right. That's not iron. XRF demonstrated that, in fact, these are all titanium minerals, ilmenite and leucoxene, and you can see the grades there are quite high, up to 18% in that little sample there. It's covered in calcrete. There's not a lot of outcrop, and on the right there, you can see another silcreted sample there with a heavy mineral band ring there. It's running about 35% titanium, and some lovely cross-bedding you can see there, so demonstrating it's a fluvial tile. That made us realise that this is, in fact, sedimentary cover, not weathered basement. As soon as we saw these sedimentary textures, we were aware of the drilling that had been done by the Mines Department back in 1991, which is some of the first South Australian Exploration Initiative drilling. When they first flew aeromagnetics out that way, they did some regional drilling to try and work out what that mag meant. These are the Carr series holes. We went straight back to those Carr series holes, which are still stored at the core library, undertook sampling of that overlying cover sand. We know from palynological data that that sand's probably late Miocene to early Pliocene. It's mapped as Algebachner. It's not Cretaceous. It's actually quite a younger sand. It's about 20 to 30 metres thick. And we were getting consistent grades of really high titanium contained within that sand. You can see also some of our outcrop samples, so some really exceptional grades of titanium in that silcreted sand. Once you drill through that silcrete zone, it becomes a free-running sand from about 5 or 6 metres. It's just the top cap which is silcreted. This is a cross-section of that Carr series once we did that reanalysis, and you can see broad intercepts of titanium. We didn't do heavy mineral separations initially, we're just doing geochemical analysis, but there's some quite high concentrations there, 4 metres at 9%, another 2 metres at 15%, just from 5 or 6 metres depth, so something very quite intriguing. And if you look at the scale there, that trend is probably about 6K, so that's something substantial, and we'd mapped it out to the west over 9K. So we thought, oh, well, this could actually be something quite significant. We put out an initial exploration target based on that surface mapping, just to give us an idea of what potential there is, and that orangey coloured outline there is really the extent of the prospective sand zone. So as you can see, the tonnage potentials are quite huge. Most recently, we completed some regional drilling. We drilled a number of basement targets, but we also did some regional drilling Rosewood prospect area where we're seeing these heavy mineral sands. The white dots there are drilling. Those holes, those traverses on the eastern side are a kilometre spacing by 200 or 400 metre spaced holes along those lines, and on the western side, 2 kilometre spacing lines. This is just an initial trial just to demonstrate, there may be something there. You can see the Carr holes in red. Now those orange dots are 1 kilometre west on section BB. These are samples we've put in, we've fast-tracked for sampling with a lab to do heavy mineral separation work. And that orange dot, another kilometre west again, is this next photo here. So this is at 10 metres. Here's our geologist Sam showing some of those grey sands at about 10 metres. That's just a handful of panning that sand. You can see it's full of titanium-bearing minerals. Whilst this was going on, we went back to the car holes in the core library. There wasn't much sample left after we'd been there the first time. There was a little bit left. And we did some compositing of those samples. We took a composite of the first 2 holes at the top and the next 2 holes along, and then we also composited the sands lower down where we're seeing mineralisation too, and ran some initial metallurgical test work. We did some standard heavy mineral separation tests, and that top interval came back, with 12% heavy mineral content and 12.5% heavy mineral content, quite consistent and fantastic grades. And that lower zone, is a respectable 7% heavy minerals. What's really great about these heavy minerals is that almost all of it is payable. 90% of that is payable. There's not much gangue there at all. Following those heavy mineral separation tests, we performed XRF analysis, and you can see here on that diagram on the left, the heavy mineral content, the titanium percent count, the titanium percent, the iron percent. You can see there's significantly more titanium there than iron. So that's very encouraging. We thought, well, actually maybe there's some higher titanium-bearing minerals present. The next test was to do XRD analysis. The XRD came back and it's showing, lo and behold, actually maybe about 20% of that content is rutile. And rutile, of course, is a very high value heavy mineral. So we're very excited, but that was quite a surprise. We could see orangey and pink sort of minerals present with our hand lens, but we didn't really know until we got that data that demonstrated actually a lot of this is high titanium-bearing minerals. We have rutile. And the remainder is leucoxene or some form of pseudo-rutile. So fantastic metallurgy associated with this mineral sands deposit too. So moving forward, as I mentioned earlier, we'll be announcing results next few weeks on our initial heavy mineral separation tests. We have then, of course, the wider areas where we have over 1,000 samples that will go into the lab. We have basement targets we've tested, and we'll be making announcements there too. And whilst that's going on in parallel, a lot of metallurgical test work. So I think just keep an eye on us and let's see where this thing goes. Thanks for your time.